Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, our second video on capture-recapture. We're just going to do some trickier examples in this just to stretch. Just a reminder what this was. We've done this in Capture and Recapture 1. It's a statistical technique using samples to estimate the size of a population. Let's get straight in and start some questions. Here's the first, pause and have a go. So you'll notice here it says you're allowed to use a calculator, and it starts off very similar to the ones we've seen. Susan wants to find an estimate for the number of fish in a lake. On Monday she catches 23 fish and marks them with a non-harmful dye. She returns the fish to the lake. On Tuesday she catches 57 fish and 13 have the dye on them. Work out an estimate for the total number of fish. The proportion of marked fish in the population is 23 out of n, where n is the population, and we're going to say that's equal to the proportion of marked fish on the recapture, which is 13 out of 57. Cross multiplying, we get 23 multiplied by 57 is equal to 13n, and therefore n is going to be equal to 23 multiplied by 57 divided by 13. Now the reason it's got a calculator is you wouldn't be expected to do this, because when you actually work this out on your calculator, you get yourself that n is equal to 100.846, etc. It's not actually a whole number. So because this is an estimate, we're not that fussed how we round it. Why don't we round it up to the nearest whole number? N is 101 fish, for example. But there would be a range accepted. 100 would also be accepted. So the reason I showed you this is because we're allowed to use a calculator, and sometimes you don't get a whole number and you've just got to round it at the end. You wouldn't be able to say your population was a decimal point population, but you must round it at the end. Here's our next question. Pause and have a go. So it looks almost identical to this one here, but there's some just tiny little tweaks in it. So let's see. Susan wants to find an estimate for the population again. On Monday she catches some fish, it doesn't tell us how many, and puts a dye on them. She returns them to the lake. On Tuesday she catches 25 fish and notices 16 of them have the dye. Then we're told, using her sampling information, she estimates the total number in the fish in the lake to be 175. So that's n. We're given n here, but we don't know how many she marked. Okay, so there's a slightly different twist here. Usually we're given the marked and we have to work out n. It's a little bit different here. So we're asked how many fish she must have marked on Monday. The proportion she marked on Monday, let's call this number x, let's say. So the proportion of marked fish in the population is x over the total number of population, which is 175 here. And that's going to be the proportion marked in the recapture, 16 over 25. So to get x, we multiply both sides by 175. X is going to be equal to 16 over 25 multiplied by 175. And you're allowed to tap that into your calculator, and you would get the answer n, or x even. X in this case is 112. So 112 fish marked on Monday. Okay, next question. Pause and have a go. So it's again about Susan, but it's just ever so slightly different. Here we're told on Monday she catches 66 fish and marks them. She returns them. On Tuesday she catches 400 fish, notes down how many had dye in them, but we're not told that. Why don't we call that Y? And then we're told that using her information she estimates the number of the fish in the lake to be 550. How many fish did she catch on Tuesday must have been marked. So of the Tuesday one, how many were marked? So the proportion of marked fish in the population is 66 out of 550. And that's going to be equal to the proportion that had dye in them on the recapture, which is Y, over how many she captured on Tuesday, 400. So multiplying both sides by 400, we would get here that y is going to be equal to 66 over 550 multiplied by 400. And you're allowed to tap that in your calculator and you get yourself the answer that y is going to be equal to 48. And they were the fish on Tuesday that were marked. Okay, so these last three questions were all about Susan. The first one was standard, but using a calculator and you had to round. The others, you didn't know some information you were normally given, but you were told the final population, so it was just working backwards. Here's another question. Pause and have a go. Now, the reason I'm showing you this question is it's about counters in a bag. This isn't a population capture recapture. You don't have to capture anything here, but you can apply the same idea. So let's think it through. Charlie has a bag with only white counters in it. She wants to estimate how many counters in the bag, so devises an experiment. She places 36 white counters, replaces 36 white counters with 37 red counters and shakes the bag up. She then takes 50 counters from the bag and notices that 5 of them are red. Work out an estimate for the number of counters in the bag originally. Now we can use the same technique here as long as you get your head around the fact that her replacing 37 white counters with 37 red counters is kind of like taking out 37 white counters and marking them. You've marked them red. So that is what that is like. So it's like capture recapture, but it's not exactly the same. So here we're going to use the idea that the proportion of red counters in the population, 37 out of the total number of counters we don't know, is going to be equal to the proportion of red counters on the second sampling from the bag. So she got 5 out of 50. So cross multiplying, we get 37 multiplied by 50 is going to equal 5 multiplied by n. So n is going to equal 37 multiplied by 50 over 5. And when you do that, you get yourself that n is equal to 370 counters, and you're done. Next one, pause and have a go. So here, there is an unknown number of beads of all colours in a jar. However, it is known that there are exactly 43 blue beads. A random sample of 57 beads is removed from the jar and 3 are blue. Work out an estimate for the total number of beads in the jar. Again, we can use this capture recapture idea, but it's not exactly capture recapture because we're not capturing things, we're just using beads in a jar. But assuming that you know there's 43 beads in the bar and the second sample beads in the jar and the second sample is random, we can say that the proportion of blue beads is 43 out of total number of beads n, and that's going to be equal to the proportion of blue beads on the sample of 57, so 3 out of the 57. And solving for n, we would get 43 multiplied by 57 is equal to 3n, dividing by 3, 43 multiplied by 57 over 3 is going to give us n. So calculators allowed 43 multiplied by 57 divided by 3 would give us 817. So n is equal to 817 beads in the jar. Okay, next question. Pause and have a go. So here we're told Charlotte has a container with only red beads and Harry has a container with only blue beads. So just drawing a little picture just to get that scenario for us. So imagine that's Charlotte's and that's Harry's. So let's say Charlotte and here Harry. We know that Charlotte only has red beads, so stuff like that, and Harry only has blue beads, so something like that. Then we're told that Charlotte and Harry swap 20 beads. This means that Charlotte gets 20 of Harry's blue beads in her container and Harry gets 20 of Charlotte's red beads in his container. So they effectively swap. So for example, it ends up, let's say, that the sum over here red, and similarly it ends up that there's some over here that are blue. That's what ends up happening. Then we're told that Charlotte now picks 80 beads from her container and notices 8 are blue, which means that the other 72 must have been red, just out of interest. And here Harry now picks 60 beads from his container and notices 48 are blue, which means that 12 were red here. If all beads were placed in one container, work out an estimate for the ratio of red to blue beads. Okay, so just thinking about this, because if we poured both of these into one container and we're trying to work out the ratio of red to blue. That's the same as the ratio of how many red beads Charlotte originally had to how many blue beads Harry originally had, because they swapped them, but now they're all getting put back in the same jar. So what we would really love to know is how many red beads originally Charlotte had, we'll call this N, and how many blue beads Harry originally had, we'll call that M. If we knew those, we could put them in a ratio together and we could work out the answer to the question. So let's see if we can use capture-recapture. We know that Charlotte, when she picked then 80 beads from a container, she noticed 8 were blue. So 8 out of 80 was the proportion that were blue. Originally, how many were blue? Well, she had all red, and when she put 20 blue in, she had 20 out of a total number we don't know, that N. Actually, I'll make it red just to make it clear. So when she swapped with Harry, she had 20 blue out of a total of N. Now, if you solve this for N, you would multiply both sides by 80, let's say. So we would get 20 multiplied by 80 is equal to 8N. And dividing both sides by 8, you would get yourself, in this particular case, N is equal to 200. Okay? What about in Harry's situation? That was Charlotte. What about over here in Harry's? Well, Harry picked 60 beads, and he noticed that 48 were blue. Now the problem is we don't know how many blue he originally had, so we're going to have to work with his red numbers. So if 48 were blue, 12 were red, okay? So his proportion of reds was 12 out of 60. And what was his proportion of reds originally? Well, we know how many reds he had because Charlotte gave him 20, so it's 20 out of his total number of beads, which is M. So we had to swap over here to red for Harry because we knew how many reds he had. We don't know how many blues he had. So solving here for M, we would get 20 multiplied by 60 is equal to 12 multiplied by M. And solving for M, you would get that M is 100. So 20 times 60 divided by 12 would give you that M is equal to 100. And the original question asked us for the ratio of red to blue beads, okay, if all were placed together. Well, that's just the ratio of N to M, because originally Charlotte had all the red ones and Harry had all the blue ones. So we have found what N and M are. So if we want the ratio of red to blue, the red was N, that's just N to M, and N was 200 and M was 100, and simplifying this ratio, dividing both sides by 100, we would get 2 to 1, and we're done. And that's it for this particular video. Thanks for watching.